In this video, we will learn how to differentiate functions of the type a to the x and log of x to the base a. First, let us tackle the function a to the x. So let's write down y is equal to a to the power x. Now, you all know the answer to the problem of y equal to e to the x. Okay, so the derivative of that is simply e to the x. But when the base is no longer e, it is some other thing, then we have to be a little bit careful. So the best way to actually figure this out is use the idea developed in the previous video where we have the power in the form of another function. So here we could take natural logs of both sides and write this as ln y equals ln of a to the power x. Now this will simplify the right hand side to x times ln of a. Okay, we're now ready to differentiate both sides. So let's write this extra step. Ln y, the derivative of ln y is equal to x times the derivative, sorry, x times l, the derivative of x times ln a. Okay, the derivative of ln y is 1 over y times y prime. Clearly, we cannot forget that we have to apply the chain rule here. And on the right hand side, all we need to do is differentiate x because ln a is a constant. So we get x prime times ln of a, which is simply ln of a. So therefore, y prime is equal to y times ln of a, which is essentially a to the x ln of a. Okay, so a simple example here would be, what is the, if y is equal to 2 to the power x, okay, then y prime, if we use this formula, is going to be 2 to the x, and then we have to multiply it by ln of 2. Okay, so very simple, but something that you could derive very easily using the log stuff that we developed in the previous video. Let us tackle now the derivative of log of x to some base other than e. Okay, we already know the answer to this one. We know what d by dx of ln of x is. We know that this is simply equal to 1 divided by x. However, when the base is something else, what do you do? Okay, so here we can use a relationship from logs, which is essentially log of a to some base b. It's called the change of base formula, is equal to log of a to some base c divided by log of b to some common base c. Okay, so what we'll do is, in this problem, instead of using some just random base c, we will use the base e. Okay, and rewrite this as y equals, first let me write this as log of x to the base e divided by log of a to the base e. And now we know that each of these are simply ln x over ln a. We're now ready to differentiate both sides and find y prime is equal to 1 over ln a, which is simply a constant, times ln x prime. And we already know the answer to the derivative of ln x. So this happens to be 1 over ln a multiplied by 1 over x. And we can just write this nicely as 1 over x times ln of a. Okay, so if we had to apply this to some situation, let's say we were given the function y equals log of say x, just log of x. Okay, the derivative of this would be, now when we say log x, you all understand it is essentially log to the base 10. So we could first rewrite this as ln x over ln of 10. Okay, and then when we differentiate it, we would essentially end up with 1 over x ln 10. All right, so hope that helps in differentiating these two functions.